So I told Sam if we get this right, we can kick off our stand-up comedy shtick. So let us know how we do. But I'm Captain Matt Friedel. I'm an active duty Marine Corps captain. And Sam Pratt, he's our lead engineer that works at Naval Surface Warfare Center, Carter Rock. So we're going to talk a lot about 3D printing here, but that's just a tool that we've used to kind of tap into the boldness that we found within the Marine Corps. So Marines have always had problems, and Marines have always had issues, and we've solved those problems with the tools that we had. Baling wire, duct tape, anything you can find to solve your problems. Now, just recently, we've come to find that the tools available to us are a lot more advanced. Now we can make things we haven't been able to make before. And what does that mean for us as a warfighting force? So, Sam, I'll let you introduce yourself. I'll take the clicker if you want.
Sure. So like Matt said, my name's Sam Pratt. I'm an engineer at the Naval Surface Warfare Center Carter Rock Division, just up the road outside of Bethesda. So if you drive up to Clara Barton, you've driven past it. And what I do is work with Matt, right? So what we try to do is support Marines in the field with equipment. So if we have a Marine that has something that's broken, can we get them a printer? Can we get them a CNC machine part to fix that problem? Basically, it's kind of a tech support help desk for everything a Marine carries around. And if we can add a manufacturing capability, a 3D printer to that kit, that enables them to maybe make those parts themselves without needing to reach back to a supply chain that might be 4,000 miles away and across the
That's
ocean.
right, and that's what it comes back to, an IT help desk, but for material solutions. So I'm leaving this slide up here so you guys can see my Twitter handle. I officially have like 21 followers, so anybody who wants to follow me, I have really interesting things to say sometimes. So we're going to talk about what we've done and how we've done it. So it's not Sam and I doing anything, right? It's us seeing an opportunity and tapping into the frustrations and complaints of Marines around the world. So it's a saying that says a complaining Marine is a happy Marine, all right? So we like it when it rains, we like it when we're dirty, we like it when things are miserable. But Marines complain and then usually don't do anything about it because they generally can't. We want to help them affect their environment more often and to a higher extent. So what have we done? So I'll let Sam talk about the F-35 part and why that's so important to what we did.
Sure. So that photo is an F-35 taking off from an amphibious assault ship.
Isn't that you flying it, Sam?
I wish. Yeah, they don't let me do that. But it's a great example, right? So an F-35 is a $120 million aircraft with a couple of 100,000 parts, right? It takes a lot to maintain one of those. It takes a lot, especially out in the middle of the ocean. And we happened to be underway with the Marines on board that ship when one of their F-35s went down for want of a fairly small part, about 1.25 inches long bumper, really, as part of its landing gear system. But that bumper is not available by itself. You have to buy the next higher level assembly, which is tens of thousands of dollars. And in addition to being very expensive, they were only located in California. So we were in the South Pacific Ocean. So what that means then is that you put that higher level assembly on a plane, fly it to Hawaii, stop there, fly it to Okinawa, put it on a helicopter, fly it out to the ship, take the little 1.25 inch long bumper that you need off, put that on the plane, and fly the rest of it all the way back to California. So your plane is down that whole time until you can get that little bumper. And what we found, actually, is that the Marines had brought a printer on board themselves because they wanted to have the capability. And
that we didn't know about until Sam came aboard to do a class on 3D printing, and one had pulled one out from under his rack and said, hey, wait, I got one here.
Yeah, exactly. And it's a great example, right? So these guys the Marines want this capability so bad that this Marine carried a printer onto the ship himself so that he would be able to use it underway to fix problems that he saw. So it's a great example of the users are really driving the innovation here. We're just trying to support them in as much as we can. Mm-hmm. And so they had actually already designed the part, but couldn't figure out a couple of minor sizing issues that are kind of not the story, but really the more interesting one was whether or not they were allowed to put it on the plane. So they can make the part, but you got to be sure that it's as good as the original part and doesn't pose a risk to the safety of the flight crew and all those things. And so that's really where the push comes, is what Matt and I's role is to clear the road for these Marines so that when they make a part like this that takes, in this case, one of the 6 F-35s on that ship that was broken and makes it not broken, that they're allowed to do that and allowed to do it safely. Because it's a huge enabler, whether that's that F-35 or Marines in Indonesia doing tsunami relief or on the east coast of the United States, being able to make the part you need in the field is a huge force multiplier.
Right, and being able to improve those parts too. So the second example we have is a snowshoe clip. So we have Marines at our Mountain Warfare Training Center in Bridgeport, California, have snowshoes. And they have clips on them. And when they break, their snowshoes fall off. And you can imagine during a 30-mile hike in the snow, if your snowshoe falls off, you're going to have a bad day. So these Marines realized that and said, hey, we can't buy these. We have to buy a higher assembly, and it's just not feasible to carry around full footwear, while you're hiking with weapons and equipment and warm clothes. So they just wanted to carry around these clips that they couldn't buy by themselves. So the Marine emailed us. He sent us a picture of the part next to a ruler, and we were able to reverse engineer it via that picture next to a ruler. And not only do we reverse engineer it, we ran it through some modeling software to say, hey, how can we make this thing stronger so the next one doesn't break? And then sent some designs to them. They had a 3D printer. They printed some of them off. They said, yeah, it doesn't work. Change something here and there. Sent us the design back. We ran some more models, and eventually now we have a snowshoe clip that back and forth a couple of times. But now that Marine has a better part in the field because he was so close to the problem, which is pretty game-changing. So, and then I'll talk about the drones, because I forgot about the movie. Yes, ma'am. Thank you. So last year, and in the write-up, we talked about combat drones. So last year, actually 2 years ago, the Commandant of the Marine Corps, the highest-ranking Marine, in front of everybody said, I want a drone in every rifle squad by the end of next year. He said that, and what happened at the end of next year? There was not a drone in every rifle squad. So we're talking cheap, commercial, off-the-shelf things that the enemy has access to that our Marines don't have because of a myriad of issues. But Sam and I saw that as an opportunity, and we went ahead and found a design to 3D print drones. We found out how to make them, and then we went around the world and taught Marines how to make their own drones. And now we have this drone that's actually a thing that Marines can download, print, and actually make, which is a pretty neat tool. So,
but it's a part of a bigger kind of pipeline, right? The drone's a great example of a capability that didn't exist in the Marine Corps beforehand, right? So the Marines didn't have a way to look over the hill that's in front of them. But if you give them the capability to manufacture things in the field and you teach them some skills about how to assemble things and how to design things, they can make it themselves, they can improve it themselves and share those lessons with other Marines so that, as Matt likes to joke, they're sort of like the Borg, right? Somebody figures out a solution that solves a problem and sends it out to everybody. And we can not just let everybody know that there's a solution, but they can make it and install it themselves.
Mm-hmm. That's true. And we also say that a bored Marine is a dangerous Marine. So we like to keep our Marines engaged and active. So would you mind playing that video? So this has less to do with the Marine engagement we talk about, but this is what I love doing. It's printing concrete. So last month we 3D printed a 500 square foot building in 14 hours. All the news articles will say 40, but the printer was running for 14 hours. And it would break and we'd have to fix it and stuff. So 14 hours. Yeah, go ahead and play it. And I don't do very well in interviews, so excuse me in this film here. Fleet Marines 3D printed the largest concrete structure in North America over the past 2 days. We've been planning this event for over 2 years. Last year we were able to print the actual test walls that we're utilizing. So utilizing 3D printing has a lot of facets that are interesting to the Marine Corps.
Well, the main objective for developing this technology was to remove Marines from dangerous situations and also reduce manpower requirements.
We need to build things. We need to build walls. We need to build dams. We need to build bridges and schools and community centers. As an expeditionary force in readiness, we're expected to be prepared for the unexpected. Using technologies like these enable us to make those decisions and provide material solutions to those problems faster.
Kind of a first for me, being part of the world first, I guess. It's kind of cutting edge of technology.
We'd be able to print those engineering assets right on site when needed. So what we had to do there was we printed half the building, and then we actually had to move the printer because the printer wasn't designed to 3D print the entire building. So we just took the little printer we had and printed 2 walls. Now the building has a roof on it, and we're installing windows and doors. So The Marines aren't going to 3D print buildings when we go forward, but we are going to print bridges and walls, and we do a lot of construction and humanitarian aid and disaster relief missions. So the Marine Corps and Navy are usually the first on site when a disaster happens, whether it's the Philippines or Thailand or Haiti. We bring a lot of food and water, and we're really good at food and water. We're not so good at shelter. So how great would it be for us to bring a machine that we can start rebuilding those communities as we step ashore? So, we 3D print concrete. All right. So why have we done it? I think we realized there was a need to help Marines out and help them help themselves. So we always say that the person that's closest to the solution is the one that's closest to the problem. And so a Marine forward has a lot of problems, right? So in his brain, or her brain, they're thinking about a lot of solutions that are cranking through. And what are those solutions? I always use the term, and I say this in the podcast, but we want to be like the Borg, if anybody's familiar with Star Trek, where when one learns something, we want everyone else to learn it as fast as possible. And so we see this as a transition point to that capability, because Marines usually encounter some of the same problems, but they all have different solutions for those. So sorry, Sam. Our main thing is centered around the Marine Maker website. It's a collaboration portal, kind of like a Thingiverse. It's closed to the community, but we'll talk about a open community that you guys can access to a little bit later. But it's been a good experience, and Sam and I are experiencing a lot of demand for it.
Yeah, absolutely, and that's been one of the things that's really exciting to see about this. So about 2.5 years ago, there were a half a dozen printers across kind of the Marine Corps enterprise, mostly in labs or in some cases with a few extremely driven Marines that were trying stuff out. Today, there's something like 150 to 200 printers deployed at every Marine Corps base that you can imagine, Korea to Kuwait, everywhere in between, and about 1,000, a little more than 1,000 Marines that have been trained on how to operate them, as well as how to design for them so that they can really leverage the capability. And the Marine Maker website that Matt was talking about is really a big part of our ability to do that, because we can share that knowledge and that training and the resources with everybody that is a part of the community.
Right. And so we also have some community engagement efforts too. So on the left is, Lonnie Love, you heard him on the podcast. We work with Oak Ridge National Labs quite a bit because they are just a massive leader in additive manufacturing. Sam Summers down there in where is it, Knoxville?
Yeah, I spent quite a lot of time with the folks down there that actually printed that car.
Yeah, so that's the Commandant of the Marine Corps, and at the time, the Deputy Commandant of Installation and Logistics, driving the Strati, a 3D printed car. So you can't see it, but he's smiling. Why the Strati? Well, we partnered with some companies, Local Motors being kind of the main lead on it, and we launched a challenge on their Launch Forth platform to say, hey, we're getting a lot of success sourcing solutions from inside the Marine Corps. What if we open that up to the community and the worldwide community and see what solutions people are coming up with to our specific problems? So there's a link on the next page down below, that launchforth.io, launchforth. So we're actually in the final stages of a marine logistics vehicle challenge that they're building a minimum viable product right now in Arizona that we can go out into the field and test. So we're circumventing the acquisition process there. So the normal government acquisition process is really fast and efficient. So we're trying to get faster and more efficient, which is neat. So crowdsource ideas, do minimum viable products, kick it out to Marines, get their feedback on it, and either kill it or put it into production. And that's what we're trying to do with that Launch Forth website. And you can hear Sam talk more on this NextGov podcast. Once you get me into concrete, I start talking louder and faster. So I apologize about that. But anything else, Sam?
No, not at all. Thanks for having us.
Yeah, thanks, guys. Bye.